In this video, we're going to look at graphing in intercept form. And the specific function we're going to graph today is where y is equal to a negative 2 times x minus 2 quantity times x minus 4 quantity. Okay? So again, some specific properties that the intercept form has is, well, first off, we've got the general equation where y is equal to a times x minus p and x minus q. Q. Okay. Y is equal to x minus a. Again, the general form of this is y is equal to a times x minus p quantity times quantity x minus q, closed quantity. Okay. And a, there that is again. Okay. Every time you see the a, that a is dictating whether we're opening up or down, or whether we're skinnier or wider than the parent function y is equal to x squared. Interesting things about this one. P and Q are x-intercepts, which means that P value is equal to, well, it's x minus P, here's x minus 2, so P is equal to 2. And Q, here it's x minus Q, here we've got x minus 4. Because it's the same pattern, x minus and x minus, you write down exactly what you see. So Q is actually equal to 4. What this gives us are two x-intercepts. These are values of x where we intercept the x-axis. Okay? So I can actually plot this. At 1, 2, I've got a big point. And 2 more over. At 4, I have another big point. Okay? Because again, all x-intercepts have the form for a point x, comma, 0. Okay, so it's 2, 0, and 4, 0. Okay? Our axis of symmetry in intercept form is given to us as the line x is equal to, so it's a vertical line, p plus q, all divided by 2. Well, p is 2 plus q, or 4, all divided by 2. Well, that gives me 6 over 2, or positive 3. So the line x equals 3 is the axis of symmetry. Okay, I'll take and draw that in right now. It's this vertical line here. Okay. Again, something that's always associated with the axis of symmetry is that's where our vertex, the highest or lowest point of the graph, lies. So I'm just going to take and plug in 3 into my equation. So when x equals 3, y is equal to negative 2 times 3 minus 1 times 3 minus 4. Oh, it's not 3 minus 1, that's 3 minus 2. Okay, 3 minus 2. Well, that gives me y being equal to negative 2 times 3 minus 2, or positive 1, times 3 minus 4, or negative 1. Negative 2 times 1 is a negative 2, times a negative 1, it's going to give me a positive 2. So my vertex is at 3, positive 2. So here again, I'm on that axis of symmetry. And at 3, 2, I have my vertex. Okay, great. Well, we've already got 1, 2, 3 of our 5 points. Again, that minimum of 5 points that we need to be able to actually put a parabola to this and let it, reflect pretty closely what we're looking for. Okay, so we need to find one other point that's not, a positive 2, not positive 4, and not positive 3, because those values are already graphed. So choose one point. I'm going to choose one point over here. I'm going to choose it where x equals 1. Okay? So evaluating the x equals 1 spot. When x equals 1, y is equal to a negative 2 times our x value, 1, minus 2, times our x value minus 4, or 1 minus 4. So that's a negative 2 times 1 minus 2, or negative 1, times 1 minus 4, or a negative 3. Negative 2 times a negative 1 is positive 2 times a negative 3. 2 times a negative 3. Our y value here is going to be at negative 6. So the point again is 1, negative 6. So here we are at 1, and we need to go down 6 units. 1, 2, 3, 4, 5, and 6. There's our fourth point, and to get that fifth point, again, we use our axes of symmetry. We are 1, 2 units away from the axes of symmetry. So we're going to go 1, 2 units away on the other side and draw that same point. Okay? Now we connect with our U. Draw your arrows to indicate that it goes on forever. And there you have it, graphing in intercept form.